Summer, can you say hi really quickly?
Hello.
Hello, that's Summer Ash over there. She's going to be our moderator, sort of running the discussion here today. Summer, thank you so much for joining us. In chat, y'all let me know if you can hear Summer just fine. Also, right up above me, this is sort of Brady Bunch style, we've got Bob Plummer, and I've put slash squad there, but really I should have put slash Rover Dude. If you ever played Kerbal before, you've probably heard the name Rover Dude. I hope it's okay for me to say that, Bob.
Oh,
Um,
absolutely.
but he's up there. Chat, can y'all hear Bob okay? And then last but not least, up in the other corner over there, Jason Craig with the JPL, NASA's Jet Propulsion Laboratory. Jason, say hi real quick. Let's make sure everybody can hear you.
Hello, everyone. Check, check. 1, 2.
I like it. All right. Everybody said we can hear Summer. We can hear Bob. Summer, y'all take it away. I think we're good to go here.
All right. I feel left out. I don't have a virtual background. I almost did, but then you couldn't see my earrings. And so that's why sometimes I forego them. Anyway, hi, everybody. My name is Summer Ash. I am an astrophysicist and science communicator. And I have come to science communication via aerospace engineering and radio astronomy. But I just pretty much love to talk about space, which is why I'm thrilled to be here as always. I'm excited today to talk about all these different ways that we can visualize spaceflight. And today I'm joined, as Das Hardy sort of rolled through, by Jason Craig, who is a 3D software developer at JPL. He's been there 15 years. And we're going to hear all about NASA's eyes on X, where X is everything in the universe, pretty much. And I'm also joined by Bob Palmer, who is a software engineer and freelance game developer, and who also does a lot with the Kerball space program, which we are also going to dive into. So welcome, gentlemen. Glad to have both of you with me.
Thank you.
Thanks. Happy to be here.
So just to get everyone on the same page, because I know that we're going to have a Twitch audience, but we also have people tuning in who don't really know much about the Kerball space program. Bob, could you give just a little overview of that?
Sure. So KSP is about Kerbals. These little 3-foot-tall green guys who have boundless enthusiasm and no regard for safety. So you basically build rockets, spaceships, your own missions. It's a sandbox game, similar to say, Minecraft, other games, and there's a Kerbal. And again, the idea is you build rockets, you build missions. It's a very scaled down universe, right? So it's about half scale of ours, maybe a bit smaller than that. And yeah, that's kind of the short version. I've been working on KSP for over 5 years now, both KSP 1 and KSP 2.
Exciting. Is KSP 2 already out?
Not yet. It will come out in a year that starts with a 2.
So anytime, really. And Jason, I realized also that I don't remember if Das spelled out JPL, but for those that don't know, that's the Jet Propulsion Laboratory. And how long have you been there? 15 years? Has it all been with the eyes on the solar system?
No, it hasn't. I actually started out with rendered animations. So the scientists wanted to get really, really accurate representation of what the spacecraft is doing out in space. And then they wanted to get it to Hollywood levels. So I was initially hired as the accuracy guy for physics and also with 3D modeling package called Lightwave. And so those together, I oversaw like the Saturn orbit insertion and Mars Reconnaissance orbiter insertion to make sure all the spacecraft movements were okay and to get it in 3D and nice Hollywood level animations. So, and yes, 15 years.
Nice. So can you give sort of your elevator pitch or your spiel about what the EYES program is?
Absolutely. Love to. Okay. You got the homepage up. Nice, Daz. Nice. Yeah. So eyes.nasa.gov is a free resource to the entire world. It is a real-time 3D simulation of over 100 NASA missions for over 100 years. So basically you can go from 1949 to 2050 and you can rewind the entire solar system and it's interactive. Now what you can download there on that webpage, you click the blue button. It's for PC or Mac, laptop or desktop only. But since mobile is the future, we are transitioning to the web. So yeah, there's the, once you install it, you get a little icon on your desktop and then you have all those options to go with. But the big flagship is advanced Eyes on the Solar System. So you can see DOS launch that, please. Oh, that's the web version. So this is actually our live web version that you can get on your phone right now. And that's at eyes.nasa.gov/apps/orrery.
Orrery. I like it.
Very bad word.
A very
Estuary.
obscure word.
Yeah, it's really in the pocket for space enthusiasts. So ORRERY. It's like those mechanical solar systems they used to make to show everything. Anyway, that's live. You can look at the Perseverance cruise stage, the next rover. So we're on the web, and of course we are also on your desktop and laptop. So Daz, can we go to the Unity-based version, the video game version, please?
Sure. That's this one here, the app.
Yep, Advanced Solar System.
All right, advanced right there. You got it.
Yeah. All right, so when you open it up, you're basically in control of the whole solar system. Can you go over to the bookmarks on the bottom left and pull up Outer Planet Missions?
Absolutely. Give me just 1 second here.
And we're just going to show the image that's on the advertisement here. We're going to do Cassini's plunge through the plumes of Enceladus, a moon of Saturn. So this was incredible. This was in October 28th, 2015. And we actually sent our $2 billion spacecraft through an unknown geyser from a moon in space.
All right, so we wanted to go to tours and features. Is that where you're looking, or
Bottom left pull up menu down there.
bottom left pull up menu? I got a destination thing.
Yes,
How's that?
that's it. Go to Spacecraft,
Alrighty.
Outer Planet Missions,
Outer Planet Mission.
Cassini. Open the Cassini tiny caret. It's the UI is being updated. It's a little small.
Now, are these all the historic missions, or they're like what ifs or future ones as well?
So just to continue my elevator pitch. So now you're in control. You can fast forward or rewind. Go grab the your speed and rate slider and just move it back and forth. Yeah, that's good. So you can see where you are. Boom, there's launch. And you can go through the entire mission. And the slower one is the one next to it, the your speed and rate one.
Gotcha.
But can you go back to that bookmark, destination bookmark, and open the caret next to Cassini? It's a little small. Yeah, that one. Now do Enceladus flyby. And everybody at home, you can do this too. So this is nuts. So this is real. This is not science fiction. This happened with your taxpayer dollars. We sent our mission through these geysers of unknown substance. Now we're pretty confident it's water, but we don't want to guess. We want to know. So we flew through it. We put our spectrometer right up front, tasted it, touched it. It is in fact 99% water, but even better, 1% organics. So Dawes, can you hit the full lighting? It's the fourth button down on the right. Let's light up Enceladus. There we go. And crank it up to look at it. Those tiger stripes there, they're all the water with organics is spewing out of there 24/7. And we didn't know that. We did not know that until we sent the mission. That spacecraft found that. And now that made this moon go top of the list of exploration. We want to send an eel down into that crevice and look for signs of life. So anyway, this is EYES. You can play with it. You can see what's going on. All of the missions that taxpayers funds, you can check them out, see what's going on. You can land the rover on Mars. It's great.
So for that Cassini, that visualization right there, you went and did that after the fact with the data because are the plumes more like they're accurate based on that flyby?
Yeah, the plumes are based on imagery that we received. They're not, they're always things you've got to compromise on because they're so tiny. These are very, very small particles, ice. They're tiny ice particles, but there's ammonia, there's methane. And underneath Enceladus is a subsurface ocean full of water and organics. And thanks to tidal forces from Saturn, there's energy. And those three ingredients, we get life.
Magic. Yeah.
So anyway, you can check it out. It's free to everybody. And then the web version, you can also see.
Oh, that's really cool. Bob, have you ever built Cassini in Kerball?
I have not built. I'm sure our folks have. We actually do have a lot of fairly realistic parts that we use. So actually, as I asked Jason, so your team does all the parts, correct?
Yes, we build all.
And these are the same ones we see when we go to like the NASA. We see all the part libraries that are really kind of play around with.
Yeah, you go to the just Google NASA 3D models, and it's a site from Ames, which is a NASA center. And you look for the models that are verified from us. And you can download Cassini, the exact one you see there right now, in Blender. So you get it in Blender.
Excellent. I have borrowed many
There
of
you
these.
go.
There you go. So like if you go down to Cassini, you can download it. It's in Blender. You're free to use it as you see fit.
Actually, and as you want to bring up the orbital pod A.
Oh, not that one.
Oh,
The other one.
the other one.
There's an STL. There's a printable one, which isn't, you got a 3D printer, but then the model I showed is the other one.
That's cool.
So all our stuff is free. You guys pay for it, so it's free.
We haven't built Cassini, but this actually is from Kerbal Space Program 2, and we did do the Webb telescope.
I noticed that was in the drawing.
And
I was going to ask you.
the fun part there was trying to figure out exactly how that thing collapses. I've spent hours on NASA videos on that same website trying to how to do all the pieces where it has the whole thing fold and properly collapse down into our KSP2 orbital science.
Fun fact, we talked about that in our June virtual astronomy live with the web operations manager who kind of helped figure out how that works.
It was fun. I'll just leave it at that. It was an origami. I was very impressed when it was all done being rigged up.
Yeah. And so do you have what's the funnest / coolest, whichever way you want to interpret that, thing that you have built or designed in the Kerbal space program?
I think one of the funnest ones, I think there's a picture of our F1 engine. This is for our Making History mod. So again, the idea was, or expansion, excuse me, to basically take a bunch of historic parts. And the problem is in Kerbal, everything's scaled down, right? Kerbal, these little 3-foot tall guys, everything's a much smaller scale. So again, the idea of, making things that are, distinctly a tip of the hat to the real model. And things like, ours, they're smaller, they're a bit different. I think the F1 engine, which I think you see there in the middle, you probably think a close-up of that one there. That one was great. That's a really amazing piece of Apollo hardware, and just the gimbal mechanism. That thing it's not easily visible. It was ridiculous trying to figure out how to make that gimbal properly work so it actually moves like a real F1, despite being a small kind of toy version. Now, as a point for Jason too, is what are your poly count budgets like for your stuff with eyes?
Over time, we've increased them, but like 20,000 maybe for a normal satellite, and then that goes way up for something like the rover. We jack that way up, go up to 400,000 sometimes. But we're still keeping in mind the web. We're doing everything in GLTFs now as well as Blender, so we're going to put those out too. And then you can just embed them in your website.
Yeah, one of our considerations, even for Kerbal, for our parts, say KSP1 as an example, we try to keep maybe 1,000, 500 for some pieces. Yeah. That F1 was probably, I think at the time it was fun. It was probably one of the more complex parts, and that's clocked at about 5,000. I think a point of comparison, if you look at KSP2, I think that lab we showed earlier, that's probably about 20, 30,000. And we have some parts that scale to like 90,000 poly count now. And then for those that aren't video game developers, if you imagine a geometric object with multiple sides, so that piece right there probably has 30,000 little flat planes that make up all the geometry, which is a huge jump from what we had for Kerbal 1.
Bob, the first thing we do is strip out the guts from the CAD because that's just a mess. And we can't show that anyway. We'd be thrown in jail because it's classified. So we strip out the guts from the CAD, make our little surface-only model, and try to make it look good.
Mm-hmm. Now, they've been great. I think the orbital pod B, if you have one of that, I think that one I used that. I found your Voyager model, and that was the basis for the magnemeter boom that we kind of sold. This one here is actually a cross between the Voyager one and we stole one from ESA too. So we kind of look at how it looks, how it collapses, and again, all these parts that we have to do are all animated. They all have to mechanically work. So that boom technically fits in that canister. All the pieces fold, the cameras all fold. The engines gimbal correctly. There's no frozen joints, things like that. So I've probably learned more about rocket science than I ever really wanted to know by working on Kerbal.
And you didn't start in rockets or engineering, right?
No, I do very boring corporate line of business application stuff as my day job. And I started playing Kerbal, loved the idea, loved the game, started building mods for it, and then got brought on about 5 years ago, before launch actually, with the KSP1 team, do mostly development. So things like the resource system, ISRU, things like the communications network, and a lot of the core features. Moved into parts with the expansions, and for KSP2, I'm focusing mostly on part design and parts. So mostly the boxes, not the textures, but the initial model development.
Okay. So the Voyager thing reminded me of DOS. I was wondering if you could bring up Voyager 2 in eyes, right? Because today's the anniversary of the launch of Voyager 2 in 1977.
Oh, right.
So let's see where it is now.
Oh, it's way out there. It's so far away that Pluto looks tiny.
I know.
And
We
if
all
you,
agree that Pluto is a planet, correct?
it is not a planet, it is a dwarf planet.
Oh no.
If you go to DSN now, Voyager was phoning home earlier. If we can take a look at DSN now, let's see if it's talking to us right now. Now that's nuts. Here it is.
Oh, that's the coolest thing. I love the Deep Space Network. One of my favorites.
43 years later. Is it phoning home right now? Let's see.
Is anyone of those?
It was earlier. But look what's phoning home now. Like the top one in Madrid, the third one over, that's Juno. That's orbiting Jupiter right now on solar panels. It's an amazing mission. Of course, you can see it in eyes. So we're always phoning home. This is one of our products. You can just bring up anytime. See what you're getting.
I often bring up, sometimes because I'm so nerdy like that, I'll bring up the Deep Space Network every morning just to be like, who are we talking to now? Or who's talking now? And it's just kind of wild, though, to think that signal's happening right now. Like we are communicating with these probes that have been out there for so long or just got there.
Yeah, it's amazing. DOS, crank it around. Let's see the solar panels. Yeah, there you go. So yeah, each solar panel is the size of a bus.
Wow.
You need that. As the inverse square law tells us, you need a lot of sunlight to power that thing. Hit the compare size button so I can show you that bus.
Oh.
Well, that's right. It has the objects in there, like objects that we know.
That's right. So, yeah.
Nice.
Keep clicking to the right till you get to the bus and a human being. Oh, that'll work. That goes. Just park it.
There's scientists.
There's
There
the
we go.
bus.
Compared to a scientist.
Yeah. No
That's
space suit on our scientists. Yeah, show the bus. So there you go. That's how big that thing is.
Oh, right. Each arm of them.
Each arm is a bus. Isn't that crazy? This is how we revealed the top of Jupiter. We found the top of Jupiter has these beautiful Van Gogh patterns. Dawes, can you go to Jupiter real quick?
Sure.
Let's look at the North or South Pole. We did not know. We didn't have a clue this was so pretty and Van Gogh-esque. So crank up to the North or South Pole.
Yeah, I feel like Jupiter is more Van Gogh than Van Gogh.
Light it up in the bottom next to right. There you go. Oh, there you go. Now zoom in on that. There it is. We just got those pictures in the last 4 years. You go to any textbook, any reference in the history of time, we had no idea that was there.
How quickly are these updated? So I know we have missions out there right now. So what's the lag time between the mission pictures and it appearing on the website?
Oh, we get the best image. We get the best mosaic we can get. We don't update each individual pass. Juno goes by every 53 days, and it takes some really odd slices, and we actually use the public. So there's citizen science on this as well. There are some extremely talented people out there who mosaic this for us. And so I'm using one of the citizen scientists' mosaics right here, and it's the best available one. We also combine sometimes with Cassini or someone else's map. We combine some. But yeah, the North and South Pole are beautiful. Starry night.
So even previous spacecraft are also in here as well, even if they're now dead, right? Like is Galileo in there?
Galileo's in the Unity-based video game one that won't work on your phone. But we are building that for this. So if you switch over to the other one, we can rewind to Galileo right now and look at it. No problem. You can get in the destinations, Dust. But now, yep, it'll be in there. Galileo, there you go. And you can also pick your event there. So now we go back in time. Note the time changes on the second panel down there. We're way back in time. Look at that thing. And show the broken antenna. So the antenna never deployed all the way. So crank it over a little bit. Other side, and you can see that its little thing didn't unwrap all the way. Oh, it's too early in the mission. Get to fast forward. It's crazy.
Do you have a bad panel on Skylab as well?
No Skylab. We don't have any human manned missions.
Oh, okay.
We don't have Apollo. They didn't have the trajectory information for Apollo. They don't really have it in the same format that all the missions use now. Yeah.
But you have ISS.
Oh, absolutely. ISS is a beauty.
Jason, do you have a favorite spacecraft?
Yes, the spacecraft I've worked on. So I grew up at JPL with Cassini and with Mars Reconnaissance Orbiter. Those were kind of my first. So, and I went to the launch of MRO back in 2005, which just had an anniversary, by the way.
Right.
So I'm very attached to those. And Cassini was such an incredible mission. It's just breathtaking amount of discovery that spacecraft did, and it never failed. It never failed. Yeah. And then
all the mission extensions.
Yeah, extensions till we sent it straight into Saturn, which you can see in the program as well.
Yeah.
We self-destructed to protect the moon that might have life.
Can we pull up? So Das, we're really making you work today.
That's fine.
Can we pull up the ISS? Is that probably? Oh, well done. One of the more complex ones that you guys had to build in there.
Oh, good. You've got the imagery already on there. So if you hit HD on this, you get yesterday's mosaic of the entire Earth. So those are the actual clouds from yesterday. And let's do real lighting. Turn off that floodlight. Let's see where the Terminator is.
Ooh.
Did you re-go to it? Oh, you've got just Earth. Okay, go back to the ISS. Look, you can watch the sunset on the ISS actually, which is pretty cool. So if you just keep watching the ISS about every 45, 50 minutes, you'll see a sunset or a sunrise, which is amazing.
How current is this model right now?
It needs, I'm glad you asked that, because we are updating 3 things that need updating. Those pesky astronauts keep moving things. So there's an entire module that needs to be moved over a little bit. There's a PMA port, and there's another thing called Beam, which is like a life pod that looks like a white ball. We're about to put that on.
Yeah, we actually use the ISS style radiators for KSP-1. So those the inspiration for our different radiators we use.
Bob, I can tell you, you have many fans of Kerbal Space Program at JPL and NASA. That's for sure.
Excellent thing.
Absolutely.
Now, how many?
Go ahead.
How many polys is this model here? So this is one of your large ones, I would assume. It seems to be pretty complex.
Yeah, this is our biggest model. I want to say this is like, well, besides the rover, this is our biggest. I think this is like 100,000. Not positive, but it's pretty big.
I'll show you one of the largest from KSP2. So, do you have the Nuclear Pulse Factory 1?
Ooh.
So one thing we're doing in this one here is over 90,000 polys. It's huge. It's probably 25 meters across. Big part. So if you've ever seen the Orion drive, with the nuclear bombs that blow up and propel it through space, how would you, if you had a space colony, build brand new fuel for your Orion drive? Mm-hmm. So the whole point of how do you build? What's the idea? So while KSP-1 is historic, there's lots of reference material. There's very little, only really concept stuff for KSP-2. So I had to figure out, if we want to hop into Factory 2, what the heck would a uranium centrifuge look like? How are they designed? How do they work? I'm probably on so many watch lists now researching this stuff. So again, what's nice is we have, on the one hand, the ability to have much higher poly counts now, which is great. But these are also really, really, really big parts, since colonization is going to be a pretty big part of the game. And I felt so bad for my coworker who had to unwrap this thing and texture it.
Ooh. Wow. So in Kerball, do you have like ISS in there? I know you have like the lunar lander or Apollo things.
So it's really more of a sandbox game. So do you have our LEM? We can pop up as an example. So this is one of the challenges, right? So we don't actually build say an ISS or a lunar lander. We try to build Legos that are usable to make your own, right? So that gets kind of weird with some of the historic parts because they're not symmetrical. They are very, very single use. So how do you convert the LEM as an example, right? How do you convert this to be a reusable Lego, but still you can clearly tell it's a LEM? So things like the dimensions, it's Kerbal size. So 2 Kerbals barely fit in there. The hatch is a Kerbal hatch. So like if you look at the real one, it's very asymmetrical. Ours has symmetry for center of mass and everything else. So part of the fun about my job is figuring out how do I take something that's historic, it's realistic. How do I sprinkle that magic and make it Kerbal, which is again these little optimistic guys, no regard for safety, things blow up, and make it so it's Lego enough that people can build their own thing. I mean, so as an example, we are doing obviously colonies in KSP2 with first class parts. People do that today in KSP1, right? But mostly it's how can I creatively reuse fuel tanks, command pods, rocket engines, landing gear, girders, and so to build my own outpost or base, versus having the right first class parts. It's a balance. How much should you keep as Lego, and how much do you make single use?
Yeah,
it's always a challenge.
And the places that people can have their missions go is roughly like the solar system.
Exactly. So we have a Mars analog. We have a moon. Actually, we have 2 moons. We have a big one, a little one. Moon analogs. So it's interesting because again, these Kerbals are out there. They can go across really the entire solar system. So we have to deal with how do you land, different gravity. How do you shrink all of that into a manageable space? So, for example, you think about even why they're so small. Think about things like your payload fraction. So the payload fraction, which is basically how much payload I have compared to the rocket and the fuel. I mean, Ariane 5 is like 2.5%. It's mostly rocket, the tyranny of the rocket equation. Whereas in Kerbal, I can get 25% because it's a smaller world. So you have to have just enough where you have to do staging, but not so much that it's all fuel, all rocket. It's a little bit less fun. So even like launch times, like I can get, say, Space Shuttle Soyuz talking 10 minutes to orbit. I can get to orbit in Kerbal probably 2 minutes. So there's very short burn times, very much more compressed space, but you still want to get that feel of a real solar system. So you can go, send Kerbals to Mars. Our analog, it was called Duna. You can send them to the moon. You can recreate Apollo if you want to, but all in a much more compressed space and time scale.
Are there any plans to potentially scale it up a little bit to like the nearest star or the nearest star with planets?
Well, one thing we will say at Kerbal too is it is interplanetary. That's why you have Orion drives and some fun things. That's about as far as I can talk about on that. But if folks have been watching the trailers, there's some pretty cool stuff.
Because that also reminds me that the NASA EYES also works for exoplanets that have been detected. Right, Jason?
That is right. Das, can you bring up eyes.nasa.gov/apps/exo?
Sure. 1 second.
So we have an automatic pipeline that adds each and every new exoplanet discovery as within 6 hours of when it's found, roughly.
Really?
We use the Caltech database.
Right.
And we visualize them all. Now, there's one problem with that. We have no clue what they look like. So we guess that this Earth-like object we found might support life. Okay, X out of there. So there you go. Okay, so this is really cool. So zoom out from that a bit. These are all the exoplanets we've ever found. Now rotate. There you go.
Fantastic. I love that.
How about that for context? We are in the center of that sun right there. That's our system. And you'll note that we seem to stare off into space for a while in one place.
Yeah.
And that's exactly what we did. All right, Dawes, if you can line that up directly, line of sight where the sun is directly in front of that bulge, and you can see. And now zoom in a little bit. Watch what it'll reveal. This is nuts. It will reveal the pattern of the CCD of Kepler. Whoa!
It's my favorite. I love it.
So we stared into that corner of space for 2 years. 2 years. So now click on any one of those dots. Just click one, select anyone, double click it. And then we go.
How many do we have so far, you think, in the database?
The counts right at the beginning of the program. I think we're 4,000 something now.
Wow.
So there it is. That's a visualization of the best data we have for that. Now, where we get into the hypothetical realm is double click on one of those planets. And let's go look at its texture. So the texture is auto-generated. And so this is a Neptune-like gas giant. So we just kind of vary it up and do this and that. But if you go look at something really exciting like TRAPPIST, which was found. Type in TRAPPIST. This is the rock star of exoplanets. Ooh, choose E for Earth. E is really Earth-like. So here we are. Oh, this is all hypothetical. We have no idea what the surface looks like. This is educated guess. Now we can get spectra of maybe, a pixel. Like we're working on it with bigger, like Webb, for example. We're working on a bigger kind of spectral data. But for something like TRAPPIST, this is only 36 or 7 light years away. So conceivably, we could send a tiny thing at 0.1 the speed of light and actually get there. But otherwise, as you know, Summer, we have big problems with traveling outside of our solar system thanks to relativity.
Just a tad.
So click on the system. So this is a remarkable system because it has so many Earth-like planets. You'll notice the habitable zone is filled up pretty well. So that's the Goldilocks zone where it's just right, like Earth. But Earth is going down. Mars is going to be the Goldilocks zone in another few millennium, or more than that, actually.
A little bit more.
Quite a bit more. But yes, so we're in the Goldilocks zone now, thank goodness. But yeah, so you can go check out all the exoplanets we've ever found.
Yeah.
Anywhere in our galaxy.
Dawes, if you go back to the view of all the exoplanets in the galaxy.
Home, just hit home.
Home, wherever that was.
Where's home? There it is.
There you go. That's all of them. Oh, and you can see from Earth.
If you zoom out again and spin it around a little bit, so that you see the center, where the center of the galaxy is. Yeah, those white ones, am I correct that those are the ones that are all found like with micro lensing? Because it's a better probability if you're looking towards the center of the galaxy where there's a lot of stars that could potentially eclipse each other.
Well, click on one. You can actually find out the provenance of each and every one, including the observatories. So if you click on the planet, it should tell you, but if not, there's an observatory section in here. Go expand it there. The blue plus. Yeah, so if you go down there, you can see who discovered it and whatnot. Here's our fun thing where, if I drove a car, how long would it take?
If you could drive.
Yes. 104 billion. 21 billion, we're making progress. There you go. Micro lensing, you got it, Summer.
I feel like you should add in there, like there was somebody who made an awesome graphic of the traveling across the galaxy by different fictional spaceship.
Yeah, we need warp speed badly or we're not going anywhere. We're wormholes. We're not going anywhere. It's rough.
Yeah, so Bob, actually that brings me, in Kerball, is there any futuristic physics like that? Or is it just really strictly Newtonian?
Sure. So, obviously, Kerbal 1 is definitely historic. Kerbal 2, I'd categorize more as fairly near future. So you see in Orion, or you see things in the trailer, obviously, that are like that, but not sci-fi, not well beyond.
No wormholes to Jupiter.
It'd be nice, but sadly.
That's maybe like KSP 50.
No comment.
That's fair.
Hopefully, I'm still working on it then. We'll see.
Right.
Oh, can you click Earth on the bottom, 3 words over from the bottom? There you go. This is the view from Earth. Pick your location, and you can see which exoplanets are in the sky. Click anywhere on Earth.
Kepler field.
I see that big
So
grid, yeah.
Yeah, there you go. So now if you can scroll down, you can see the surface of Earth, and you can roll in the constellations. It's virtual astronomy, right? There you go.
Right. And the colors are kind of like the stellar
Yep.
classification.
Yep, exactly.
Red stars, red dwarfs, main
Yep.
sequence.
We
That's so
work directly with the exoplanet scientists here at JPL. They are consulted about the process of developing the software on the regular.
Oh, that's amazing. I know what I'm doing tonight.
And if anybody wants to help save Earth, we have the same thing for Earth and Earth data mapped on. So Das, can you go to app/Earth? And this is built into climate.nasa.gov also, so that you can check the latest fires. You can check carbon monoxide, carbon dioxide. You can check ozone, water vapor, etc. There you go. This is the fleet of NASA Earth missions. I bet you didn't know we had so many Earth satellites. Pretty impressive. So
How many are there? Like more than 10?
yeah, we have like 20 some, 28, 29. Yeah, so you can look at any one of them and check the vital signs. So yeah, there's ISAT-2, which hasn't been around long, but it's going to study ice for us. I would say go to vital signs and let's see how the Earth is doing. All right, so here we go. Do surface temperature. That's pretty good. Let's see how hot the world is. It's pretty hot. Yeah, go back up. You had it. The red one. Yeah. Oh yeah, we have a malfunction. You know what? We have a data. There's a problem with one of the satellite transmissions on this. Aqua has a problem right now the last 2 days. Which is unfortunate because that's our workhorse. So it's just, there's nothing wrong with the instrument. There's something wrong with the solid state recorder and getting it back down to Earth right now. But yeah, let's look at gravity. Can you go to vital signs gravity? We actually measure the fluctuating field of gravity all the time with GRACE.
I'm looking.
Grace is amazing mission.
GRACE is stunning. GRACE is an incredible achievement. It's the first mission to never actually send or receive data through the atmosphere. There's two of them, and all they do is follow each other around all day like this. And they go back and forth like an accordion.
Uh-huh.
And the amount they go back and forth dictates the changing field of gravity below.
Whoa.
And if you go over land, the question is, how in the world can land change its gravity? And the answer is something heavy is clearly moving around. And can you guess what that might be?
Liquid hot magma.
There you go. It's liquids. It's water. So go up to Greenland if you want to be depressed tonight. Go up to Greenland. Yeah. Red means there's less mass there than before. Now, let's go to the date. Click on it, and let's go back in time.
Oh no, this is going to be really sad.
Yes, it's going to be really sad. Bottom right, August, where it says August. Click on that. Oh, geez. No. We have to select the date. Oh, animate this data. Click on animate this data. I generally use the Unity version because it has more back. The data goes back a lot further. Now click the calendar icon and let's go back in time. And yeah, go back as far as you can. It's one data piece per month. So let's watch. Did Greenland ever gain ice in the last 10 years? The answer will not surprise you. So hello, depression. Greenland has been losing ice steadily, about 300 gigatons per year. And you can see that right there. Notice how the rainfall changes over land. Like if you look at the Amazon, you'll see a season. It'll go wet and dry. Purple is wet, red is dry. But you'll notice Greenland does nothing but lose ice. That's all it does. So if all of Greenland melted, 25 feet of sea level rise globally. But it would take a really long time at the rate we're at now, but things can change. But that's not the big one. Let's look at Antarctica.
It's worse.
No, it's better.
There's more.
There you go. This will prevent absolute depression. However, if anything changes, let me put it this way. If 6% of Antarctica melts, Florida is half underwater. I mean, Miami's almost underwater already. But Look at that. I mean, so you can see it losing ice on the left and gaining ice on the right. So it's almost a wash, which is great, but it's still losing slightly. The slope is still slightly negative. And that's where the Larsen ice shelf pieces keep breaking off, the size of Delaware.
Right.
And then when we get, there's a host of effects that happen from all this ice loss, sea level rise in particular. And we can also track water movement around the globe, which is, we've never been able, this plus GRACE. I mean, this GRACE tells us for the first time we can connect this to sea level, in particular, based on ice versus water versus all the other factors. It's amazing. So yeah, all the vital signs are there. You can check out how Earth's doing. Carbon dioxide, you don't want to look at that one either.
No.
Anyway.
What are some of the other vital signs, just out of the categories, out of curiosity?
We have ozone, we have sea level, we have CO2 from a couple different satellites. We have very obscure things like nitric oxide and all the molecules that actually help ozone deplete at a certain level, about 46 kilopascals up in the stratosphere. So you can monitor the ozone layer, make sure the hole is, doing okay. So just check out the vital signs menu. And on the video game one, there's a lot more data sets. So we show this all the time at JPL. We show this to Congress people. We show this to celebrities, whatever. We show all this stuff in a nice demo room. So we've got awareness is crucial. JPL's budget is huge for Earth. It's massive. It's bigger than any other NASA center. We do a lot of Earth science.
That's really cool, because I feel like I don't think I would have known that.
Right. Climate.nasa.gov really will tie you into that stuff.
That's great. Bob, do you have anything to pick our hopes up?
What's that? I was hoping there were there's good news there. My God.
Yeah.
Oh, let's do my augmented reality app for your phone. Do we have that GIF?
Yep.
I don't know where you stand on the GIF versus Jeff controversy. I'll use whichever pronunciation. So if you go to your app store right now and you type in Spacecraft AR, you can do this. So you can put the rover on your floor, actual size. There's an actual size button, and then it gets, it's an SUV, so be careful. Basically, the phone will sense a horizontal surface and put the spacecraft down. And these are our Unity models. So these are our main Unity models, Bob. And you can scale it to actual size. So just type in Spacecraft AR into your Google Play Store or App Store with iOS. And you can do this at home. It has Voyager. You can make Voyager actual size, which is massive.
How big is it? How big is it?
Oh, it's nuts. You need to go outside. It won't fit in your house. Cassini, too. Cassini's the size of a building. I like to put Cassini up against our Mars building at JPL. Then you really get the scale.
Yeah, I want to go put the Mars rover in my driveway now.
Absolutely. And you can take a picture. Put humans in it. Take a picture.
Share it.
Fun. So there's some fun, some levity.
That is some levity.
Take that.
Do you guys have stats? So, because you can download the eyes onto your desktop. So, is there do you know the number of downloads to date?
Yeah. The number of downloads pales compared to web usage. So that's another reason we're moving to the web. Also, Linux users were very upset that we were only on PC and Mac, and rightly so. So now that we're going to the web, everybody can use it. Anybody with a web browser can use it. So for something like Eyes on the Solar System, it varies. It depends on if there's some big event. It depends on if we get a push from something.
Right.
So like when we land on Mars, it'll go up. But yeah, we don't get a lot. We don't get a ton of traffic. We probably, on our best months, we get 100,000 something. And normally it's more like 50. But with the web traffic, it's pretty much like we're integrated now into solarsystem.nasa.gov, which gets millions and millions of hits. So our live solar system is there, and we get a massive amount of traffic.
Speaking of upcoming events, it's still a ways away, but since it's been postponed so many times, do you already have web already in the system?
We don't have the model for web. We have not been given the model for web.
I have one for you.
Yeah, exactly.
We are waiting for the model for web, and we will put it in. I've asked.
Mine's a little bit smaller, though.
Yeah. I did go see web physically in person in El Segundo and Northrop. So I just saw it right before the pandemic. Good timing.
Good timing. For
And the honeycomb was deployed, which was lucky. So I just went and saw it. It's pretty cool.
Yeah, each one of those honeycombs is like the height of a person.
Yeah.
Or in my case, a Kerbal.
Or a Kerball, a small person. Bob, without, I guess, breaking any contracts that you may have signed, do you have like a dream project to build or to create?
Actually, so right now I'm doing all the colony parts for Kerbal 2, which is amazing because again, folks know it from KSP1 and from my modding life, I'm all about colonization and stuff. What's kind of nice is that KSP1, you had initially rockets kind of first-class citizen. We then added space planes. So space planes, and you have a whole assembly area for that now with the spaceplane hangar. And so really what's kind of cool is with KSP2 colonization and exploration, that whole colony building experience is absolutely, first-class citizen. It's really, really, really cool stuff. So just dealing with the scale, these are, I think that you may have some pictures of the colonies from some of the footage that's already out there. Yeah, these are not small. So those pieces you see are probably 5 meters to 10 meters across. Those are big.
Yeah.
So, figuring out for little Kerbal guys, how would you build it? What would it look like? It's been absolutely fantastic. Also, how would you refuel? So, the nuclear fuel factory we're building right now, building, again, a pipeline of parts for your future Kerbal adventure. So it's kind of nice that now, even though it would definitely deprecate stuff that I would mod normally, makes me kind of sad because it's built into the game now. The fact that we can now build like stock colonies in KSP2 without it just being, mishmash rocket parts and cans and stuff, and it's actually a full-fledged colony, is really, really cool. So they actually asked what parts I wanted to kind of play with first. They gave me a list. It's a really cool list. This was actually number one on my list. Like, let me do all these first, so then we do some more fun stuff. So I've been mostly working, as you saw, the science parts and the colonization parts.
Bob, what software package do you use?
So I use Blender because Blender is awesome.
Good.
And so Blender, and then we love it. It's free, price is great, and it's a fantastic tool. And again, we see here our nuclear pulse factory, and this one, and brutal 90,000 poly is big. Pablo is one of the artists at Squad had to do the unwrapping texture on this. I apologize for like weeks. Dude, I'm so sorry I gave this to you because there's so much. But that little crane there actually moves. So you see you can see in the centrifuges, there's 2 of them with all the pipes sticking out of them. There's the giant tanks that hold the gasified uranium, and the idea you have a big cartridge there on the bottom left. Those are the actual packets of bombs that would go on an Orion rocket. You load up to it. The crane can move around. It can pick things up, and there'll be animations and stuff. And this was just an absolute blast to build. And again, there's going to be probably a lot more like this. Right? The scale is just huge. So we're having a blast. And the toughest part now, honestly, is that poly budget because there's so much piping and so much detail in these. Right. Also, because the resolution is higher in general in KSP2. Right. So if you look at KSP1, all of our rockets, whether you're tiny or huge, it's a 24-sided cylinder. We have higher fidelity in KSP2. So some of the hatches, some of the details are really intricate and been absolute blast.
Nice. How many users does it have overall? Like, what's order of magnitude?
Oh, for a Kerbal 1?
Yeah.
Yeah, I don't know off the top of my head, to be honest. A lot.
Yeah,
Daz, you might know. Did you recall Daz off the top of your head?
Me? No, I don't know.
It's a lot. many. Obviously, we're on Steam as well as you have the store too. But I'd say somebody probably a different group would know that number.
Right.
But we'll go with many, and hopefully many more.
Are there any new plans on the horizon for eyes, like maybe eyes on black holes or something like that?
Yes. Well, our ultimate goal, of course, is eyes on the universe.
Oh yeah.
So all in one, basically, go anywhere. In fact, I want to do expansion of the universe. I want to go show the diameter in light years of I want to show inflation. I want to show it all. Like that would be nuts. Now that might be a ways off, but yeah, I'd like to get other galaxies in. But
Yeah.
obviously, all of NASA's missions are in this solar system, so we'll probably just have some stuff. But yeah, I want everything all in one. And the tricky thing is data and download trade-off. So that's what's great about video games is you can download, you can get you all your texture maps, do this massive download on Steam. You can have Red Dead Redemption 2, right? But you can't do that on your phone. So we've been told, get on this phone, or we are doomed. Because the young folks, they're not going to download anything. So we need the younger audience. We want people interested in space. And if they can pull up the solar system on their phone, that's great. So we had to figure out a proprietary trajectory data reduction system where it's still being completely accurate, but we can't have that data load. So like when you load up that solar system right there on our orrery or Solar System Interactive, the data load is like 2 megs. So the whole thing.
Oh, wow.
So we had to do some magic.
That is impressive.
Yeah.
It's a lot of magic.
Yeah, but when you go somewhere else, if you go to the ISS, that's like, I don't know, 20 megs maybe. And then you see the textures, those, we tile in those textures. So like Mars also. So if you go to Mars, there's HD on that too. Yeah, go ahead and Mars. Would you Dust? Let's see our fleet. We have a nice fleet going on. Yeah. Go to MRO right there. I love Mars Reconnaissance Orbiter because I saw it launch. I worked on it with the project manager and project scientist for years. So there it is. It's been taking pictures with that telescope on the other side for 15 years. It's the best pictures ever sent from another planet. So yeah, that thing right there, you can take a picture of the rover on the surface with that thing. That thing is good to 25 centimeters per pixel from orbit.
Now, can you see the rover and MRO at the same time in a scene? Like, see if you're doing Curiosity, see the MRO going overhead, or are they separate missions?
Oh, there you go. There's the HD textures. So you can see that's where it is. So again, this is live. This is real time. This is accurate. Nothing in here is faked. Even the images are real. Obviously, there's some fakery, but the position, the orientation, the lighting, and the terrain below is all correct. So, all right, I'm gonna let you in on an Easter egg, okay?
Uh-oh.
Click the date 6 times.
Are you up there?
Yep.
Oh.
Now fast forward and rewind. Your heart's content.
Ha-ha. Am I allowed to do that?
Oh. So yeah, it'll run out of data. Just let it catch up, and you can go backwards in time. You can go forwards in time. Now the tiling will catch up, and you can do that with. Now you can watch the sunset on the.
Ah, yes.
Oh, cool.
It'll give it a second to load the HD textures here. So. Yep, we might have had a little comms hiccup there with Jason. Yeah, Summer, it looks like we may have lost Jason. Just go ahead.
It's like we're moving through time faster than he is right now.
He serves the textures from his home computer.
You should have hit that button.
Everybody clicked on HD at the same time, and they all started downloading the HD textures.
Oh no, because my next question was going to be, can you go to the rover and then see? You've seen those pictures of the rover seeing the transits of the Mars moons across the sun?
Mm-hmm.
Those are so cool. But I don't think we can go to the rovers. I think it's only the spacecraft.
Yeah, I think it is just
play with the rover, but you can't go.
Oh, you can see the rover land, the rover mission, but not the rover on the ground.
Yeah, I think that's it. So that was still really cool.
In Summer, I'll work to get Jason reconnected here. It looks like he dropped there completely from the call. So
he got way too excited.
Get those textures for us.
He's going to hand deliver the textures to everybody.
He just packed them up.
Hey, never underestimate the bandwidth of a miniature van filled with thumb drives or whatever. It used to be tape drives, I guess.
Yeah, something we said for that.
Oh, I was going the wrong way. Oops.
Yeah, we actually I don't have a picture of it, but in our Breaking Ground expansion, we actually named our little rover arms after Curiosity, Spirit. They have a little tip of the hat to the different rovers out there.
Yeah.
And the fun part there was building basically a rover arm that you could that could be put anywhere possible on a spacecraft. So you can't be sandbox. It will actually deploy without clipping things and point correctly at an object on the ground.
Right.
So just the animation, the way we have them be able to shrink and package so they are deployable, right? So they're a very small profile. But again, they could be on the side, could be on the nose. So that whole design aspect, which I think is unique with Kerbal, is that people use our stuff in just radically unanticipated ways. Think, oh yeah, this is a LEM. Oh, they turned into a ball bearing. They just use insane stuff. Apparently, our Sputnik our Sputnik, is apparently a very popular ball bearing. So one of our considerations when building parts is, should it be hollow? How should we build these? Because people are going to abuse the heck out of them. So we really try to actually into consideration. And even with part updates, like when we build, let's say, rocket decouplers are hollow. It's one of the few ring parts you have. There's certain things where we've intentionally kept more complex colliders, specifically because folks are using these for just crazy contraptions, and they're making like mecha robots and insane stuff with. It's a rocket game, but it's really it's a sandbox physics playground.
Yeah, they're making transformers essentially.
Absolutely. Oh yeah, I've seen it. I've literally seen folks make like flying transformers there, which is insane. All kinds of fun stuff.
Yeah, that seems to me like that would be such an interesting aspect of working on a project like that, is the different ways that evolve from the users of how they're playing it, using it, creating things with what you gave them. That you couldn't have predicted necessarily.
Yeah, we sit in meetings, try to design a part, and like, well, how will they use this? And we try to guess as far as our ability. We are surprised every single time. Every time.
Yeah, I bet. I mean, so, Kerball's very new to me, and I haven't actually played it yet, but I just am fascinated by the idea that so it's not only that you're building in these parts that, especially historic ones that look so much like the real thing, and people can put them together and recreate these missions, and you have the physics, but not only the physics of the actual trajectories, but the physics of, like you were talking about, like, is the engine gimbaling correctly? Like, just how individual pieces are reacting with each other, and you have to program that in.
Yeah, and Summer, I've got Jason back here, so he is back on the show. Welcome back, Jason.
You found out textures.
There's some kind of internet hiccup. There's a lot of power usage here in LA, so I don't know. Brownout, I don't know.
All good. We got you back, Jason.
And just in time for some Q&A, because I'm sure people have a lot of questions for both of you.
Oh, there are definitely a lot of questions, that's for sure.
That's why I did not have Twitch up the whole time, just in case.
Yes, well, I've been weeding out a lot of them, let's put it that way. Oops, wrong one. Whoa. There we go. I changed my scenes. There we go. Okay. So, y'all, we're getting into the part of the show here where we do some Q&A. You've been watching Bob and Jason from JPL, Bob from KSP Squad, Private Division, Kerbal 2, all over the map. He does all sorts of things. Umbra Space Industries, I could probably say that as well. But we've been sort of gathering some questions over the course of the time here, and now we've got about 30 minutes left for Q&A. So before we get too far into this, I know we've got Bob on here, and I know we've got JPL on here, and there'll be certain questions that I'm just not going to answer. I'm not going to let questions through. If you ask Jason if there are actually aliens in space and do we have any of them modeled in NASA eyes, I'm probably just going to delete that question. I'm not going to ask it. And if you ask Bob how many, Bob's already answered you. He said KSP2 will come out in a year that starts with a 2. So
guaranteed.
Like the very beginning, like 2, not anyways. So keep your questions on topic. We're here to talk about visualization of spaceflight experience. I know there's all sorts of different questions all across the map, but as we do this, please keep the questions on topic. They're moderated, etc., etc. So without further ado, Summer, we're going to hop over to do some Q&A. Thank you so much for chatting with the guys here about spaceflight visualization.
Oh, my pleasure. I'm just going to play around on some ice while you guys are talking.
That's what I've been doing. I've just been over here and I'm like, oh, I can go to this, then I can fast forward this, and I can show that. So I've been playing and showing y'all what I was doing over here. Well, let's pop over this way really quickly, y'all, and we've got a couple questions. I am going to scroll through, and again, we're looking for visualization questions about visualizing spaceflight experiences. And here's one. This looks like it's for eyes. And so it says, are the old Mariner and Pioneer spacecraft in NASA eyes, I guess, right? So, Jason.
Yeah, not all of them. Pioneer 10 and 11 are in there because
Right.
there's you can see them right there. They're way out there with Voyagers, so they're in there. The Mariners we don't have. The Rangers we don't have. Yeah, those are crashers. I'd love to have some of those crashers that just hit the moon. That'd be pretty cool, and Mars too.
Is there something that determines whether or not you have a mission? Like, does it still have to be an active mission? Is there any time that you would go back and put historic missions in, like a fly along with Apollo 13 or something like that? Or how do y'all decide what goes in and what doesn't go in?
That's a good question. For example, we are not allowed to put Chinese missions in whatsoever. Russian ones, they cooperate with space stations, so they're in there, but not their other missions.
Gotcha.
We don't even have our own Apollo missions. Basically, you have to look at when it was started, 2012. So we're going to have the majority of things from 2012 onwards and all new missions that are NASA, ESA, JAXA, Roscosmos, and maybe a couple others. We actually did we did a couple random ones. There's a lot of factors involved. But flagships, obviously, we do that. Things with a lot of attention, we do that. And like we don't do every CubeSat, we don't do every experimental test, but we do have CubeSats in there. So it really varies. And also who pays. Like some missions will give us back up the Brinks truck and give us a lot of money. Like Cassini, we made the Cassini module inside eyes is spectacular. Inside that you can watch the final transmission and you can see the speed of light.
Yep.
Take 82 minutes to get from Saturn to Earth while Cassini goes and kills itself. It's amazing. So the Cassini mission, we worked so closely with the project manager, project scientist, all the people. It was great. So, some missions are bigger and some have more political, power.
Sure.
But
more publicity, et cetera, et cetera.
Yeah, we try to put in everything we can.
Yeah.
Within time and reason and manpower. So we don't have a huge team either.
Yeah, fair enough. And you said the place you start whenever you put a spacecraft model in there is you get the CAD file, then you rip out all the guts of the CAD file. And I imagine that the Chinese space program is not sending you their CAD files, right?
No, we're not going to get those.
I'm just going to take a guess. I'm not like privy to all this information, but I'm guessing they're not sending you their CAD files.
No.
All right. Let's see here. And you could tell my question. I have monitors all over here, like my miniature mission control. And when I get a question, I look like way up at the top because that's where the questions are. This is a great one. This is from Kerball Man, and let's go both on this one. Are the interior of the spacecraft models rendered? So in eyes, can I see anything inside of a spacecraft if I zoom close enough?
No. You'll clip.
You'll start to have your face inside of an antenna or something like that, right?
Let's start clipping.
Yes, we know all about clipping. I can see if I can bring up the visualization here really quickly. But so the insides aren't modeled, and that's another thing I guess that keeps it lower bandwidth, lower size, file size, lower, et cetera, polygons.
Yep. Can't be putting in every screw. Nope.
Gotcha. And I won't ask. I know in KSP, like we have some interiors modeled in KSP. I know Rover Dude, you did a ton of that. I'm just gonna mess up and call you Rover Dude every time. So
it's fine.
I apologize. I don't know you by any other name, so it's like people calling me
Everyone knows
John.
I love IVAs.
Who's this guy? Yeah, the IVAs. You did a lot of stuff on the IVAs in Kerbal 1, right?
Well, actually, Pablo did most of those. I despise IVAs.
You despise IVAs.
Oh, I hate making those things.
You just make
it's almost like a meme in the Kerbal world of me and IVAs. So, one of my fine coworkers together for making history, and I was at KSP 1, and obviously in KSP 2, whole different kettle of fish. That I'll leave off the table for now.
That you'll leave off the table for now. One of the things I like to do in Kerbal 1 is I like to build it so that the cockpit gives you a view of something, or you have a little module that you've used as the control center for your space station, and then you put the Kerbal in there and you IVA, and you can sort of see the spacecraft docking or whatever. So features like that are definitely cool visualization features that you can build in KSP 1, and I guarantee you I'll build them in KSP 2 as well, regardless of whether or not you put them in there. Let's get another question here. This was down to some of the resolution that we have in eyes. And so the question, Jason, specifically was about what resolution can we see the gravitational anomalies in eyes. But I guess that comes down to whatever data set you're visualizing, right? So the gravitational data set that you're putting on that eyes on Earth is different than the data set for temperatures, is different than the data set for an exoplanet. Is that a way to sum it up?
Yeah, like so the data set for that gravity field is massive. It's hundreds of kilometers per pixel.
Right.
We even smooth it as well. So that's a limitation of the data set. We are not allowed to make things too fancy if they're not in actuality. Everything has to be accurate.
Gotcha.
Even smoothing it a little bit, which we do to make it look nicer. It's not, it's like we can't go any more than that.
Right. So you're using like realistic data. You're not like trying to extrapolate it or whatever, massage it so it looks better or whatever. You're trying to use the real data for real.
There's no extrapolation. There's no massaging. But like with that Earth texture you see on our solar system interactive, that's from a spacecraft that takes a full Earth mosaic every day. So that stuff is high res.
Yeah. What spacecraft was that was doing the mosaic every day? You said that yesterday or the other day.
It's a weird name. Suomi NPP. It's a joint project, and it has a really nice camera called VIIRS. It does infrared and visual.
Right.
And they do mosaics every day. Another good one is the Discover mission, which sits at a Lagrange point.
Right.
Awesome. And that has beautiful mosaics every day.
Is Discover in eyes or the web app or?
It's not on the web app. It should be
It's in the desktop app. Yeah. I have to admit, I was using the web app mostly because it had the search in it.
Right, I know.
It was really easy to just type in ISS and go. So.
Yeah, we were sure to add search this time.
Was that a big feature request? A lot of people asking to be able to search?
Yeah. The UI on the old one needs some work. So we're actually updating that entire program for the web. Eyes on the Solar System web.
Gotcha. And that makes it more accessible on mobile devices. I assume at some point you're going to have like, here's the one version that's deployed everywhere, and that's the version going forward and stuff like that. But right now you still have sort of the two. You have the web-based Ori, then you have the Unity. You said Unity, OpenGL. What's it done in?
Yeah, it's Unity.
It's Unity.
Same as us.
There you go. So that's kind of cool that the visualization program, NASA Eyes on the Solar System, Eyes on Exoplanets, like the app you download uses the same, what do I call it, graphics engine, visualization engine?
They make game engine, yeah.
Yeah. As Kerball, right?
Yep.
No,
absolutely. We hired game modelers from the industry. Like the main artist used to work at Sega, like in the 90s.
No kidding?
Yeah, he worked on like 3DO. He worked on all kinds of cool stuff. He's got some stories. So yeah, we hired game artists, lower poly kind of stuff. PlayStation 2, PlayStation 3.
Excellent. God, I always run out of time with questions. I mean, we still have lots of time for questions, but no matter what, we always run out of time because it takes people like 10 seconds to type a question in, and then we talk about it for 5 minutes, right? So I'm going to keep rolling with some questions here. Let's see here. I see so many questions. I knew this was going to happen. So many questions about gameplay mechanics in KSP2. If you're asking me exactly what happens in KSP2, I'm skipping over a lot of these questions, y'all. Just be advised. Okay, we got that one. Wow, I'm scrolling through the list of questions, going through all of those. Here was a good one. In the NASA Eyes app, is there anything where you can click on a camera and actually see the view of that camera or the ground pattern? You know how you have a cone of what the camera can see, the field of view? Is there anything like that in Eyes?
Yes. You can see the frustums of various instruments for Voyager in the Voyager module and for Cassini in the Cassini module.
Okay.
In fact, if you go into Cassini, you can do all 127 flybys of Titan, the moon of Saturn. And you can see the radar dish with its 5 wavelengths scanning and finding the northern lakes of methane on the North Pole of Titan. Gotcha. So yeah, the frustums are all up in the Cassini module, and you can see Voyager's frustums as well.
I want to see if I can show that really quickly because that's really interesting, and that's something that I've seen a lot of in Kerbal, where we have like CurbNet, and then you can set the field of view of your sensor and scan the ground differently. Because that's a real thing.
Go to Advanced Eyes, and actually no, just on the webpage you can click directly on the Cassini module launch.
All right, I'm going to see if I can get that. I think I have that here, but give me just 1 second to see.
Yeah, so for you users at home, the eyes.nasa.gov homepage, after you've downloaded and installed it, you can click directly on one of those special modules like Voyager or Cassini. Cassini's right there on the front page. It's a smaller square below.
Yep. I'm making it so we can show that real quick.
Yeah, awesome.
Is what
So yeah, we want to draw that stuff out. So we actually show drawing out each radar pass of Titan. So we mapped Titan. So we saw what's underneath. That's why you see a T-shirt that says "Surf Titan" because it has waves. You can actually surf methane lakes, and we're going. We want to go to Titan as well. It's got an atmosphere, smoggy. So you need to go to Tours and Features in the top right there.
Yep, Tours and Features, got it.
And then go to Cassini.
There you go, and just feature right there.
Yes, yep. And that'll launch the big elaborate module for the entire Cassini mission, 20 years, including every single rotation. That's
Wait,
a lot of data.
Every single rotation, like
spacecraft
rotation?
Yes, that's right. It's tricky. Right, here's the sizzle reel. There's Saturn orbit insertion in 2004, where it hits the brakes. It puts on the thrusters there. By the way, this is all completely accurate. That's exactly how far away it is. That's exactly its size. The scale is 1 to 1 to 1. Here's a moon flyby. So at the beginning, you can just put this on in the background and have it look cool.
Yeah.
But when you're ready to go in, you click the Explore button down there at the bottom.
So it's just like the reel at the bleeding, like the loading screen or something almost, I guess, huh?
Sizzle reel.
Sizzle reel. I like it.
Yeah. Okay, now on the top, you see those little buttons for navigating. Go over to the moon-looking one, about 4 or 5 over.
That one, Moon's the Saturn?
Yeah, there you go. And then click on Moon Flybys.
Moon Flybys, got it. It's almost like a tutorial teaching me. The guy who wrote the program is teaching me how to click on stuff. I like it.
Go to 127 Titan Flybys.
Really?
Yes, really. Okay, now go click on T28, the 28th flyby of Titan.
T28, the 28th flyby of Titan. There you go. Okay.
Yeah. Okay, this is the one where we revealed the northern lakes of Titan. So you can also remove the atmosphere. So look, the timeline is scrolling over to where this happened, which is pretty cool. Then it zooms in. By the way, you can click on, there you go. So there's a frustum, there's the radar. Oh, remove the atmosphere. There's an option to remove the atmosphere.
Where would I find remove atmosphere?
Should be.
Here you go, show atmosphere.
Oh, light it up too so we can see it. Do full flood lighting on the bottom right.
Yep, I got the full flood lighting.
Okay, now make it, remove that yellow gunk. There you go.
I got radar map or camera. Whoa.
Radar.
All
there
right,
you go.
buddy.
That's how we map a moon. So look at that. That's real. Cassini is taking that data. So that the data that's already there is you got it from this pass.
Wait, so for real, in the illustration here, it shows what each of the instruments was looking at, where the data came from in not real time, but this is like playing it back. Like as it flew past here, here's what that sensor looked at specifically.
Exactly. And this is the most elaborate one we've ever done. And that's because the mission really supported us. And so that little ball of little yarn there is a pretty good radar coverage of Titan. We can map the lakes, figure out where we want to land, have a look. So that's radar, but if you click on other ones, there's other categories. You can look at the visual, like the real visual cameras.
The camera mapping.
Yeah, all of that stuff is in there. And then you can, Enceladus, of course, with the plumes. That's the one. Go back to one of those Enceladus flybys.
I'm going to see if I remember how to do this. There's Enceladus. And
that's a view of the moon itself. So you have to go into the moon flybys category.
All right. See, now I'm on the spot. It's like, wait a second, how did I do that? Moon flybys. So there's moons of Saturn.
You go, that one.
And there's moon flybys. Yep, I clicked on the wrong thing.
Choose by moon.
There's Enceladus.
Yeah.
And that's the one we were flying through the plumes.
Yeah, well, this is a different one, but there's a whole bunch of flybys. One we got really close, and basically we're just super intrigued by those plumes, which unreal. They're unreal. And the spacecraft had a small damage, worry of being damaged when it flew through. There was a tiny risk. So we kind of waited to the end of the mission, near the end of the mission to go through there. And even at the end of the mission, we flew through the rings of Saturn. Like we flew between the rings, the inner rings, and the planet.
Yep.
And we put ramming position with the radar dish first to collect the particles in case it damaged Cassini, but it didn't do anything.
Real, like using the radar dish as a shield?
That's correct. You want to see it?
I've definitely done that in Kerbal.
Go click on the one next to the moons there. There's a final grand finale.
Grand finale. There you go.
Yeah, yeah. So go to final. No, go to proximal orbits. Is there proximal? I can't read it.
I mean, I'll click wherever you tell me to. Just tell me where to click.
I can't see it. It's too small on my screen.
Ah, gotcha.
Yeah, maybe I'll pin this one. Okay, there we go. All right, so look what we did. Look what we did near the end of its life. We shot the gap all the way to 2017. 20 some orbits shooting the gap, and then it self-destructed right there. So it actually went. Yeah.
So we shot the gap between the surface, the atmosphere of Saturn and the rings. We like went in between it.
Yeah, we went in between it.
All right, I gotta ask. If you had flown through the rings, would you have crashed into anything, or is it like sci-fi asteroid belts where it's actually really sparse? I mean, clearly a higher probability you might hit something, but
there's some big things in there that could mess up the spacecraft. There are pieces of particles that make up the ring the size of a house.
No kidding.
Yeah, there's like waves in there too. There's shepherd moons. There's moons in between the rings, which you can see in this module.
Yep.
Which is pretty cool. Actually, click on the grand finale button on the top right again.
Got it.
And let's go to final transmission. Here's some nerdy physics for you, which I love. I have physics background. That's the speed of light in real time. That's Cassini's final signal in 2017.
Oh, that's the signal.
That's the signal.
In real
real time. Go to, crank it down so Saturn is below us. Yeah, there you go. Now zoom out so you can follow that really, really slow speed of light. Look at that. That's the speed of light. It's too slow. We're not going anywhere unless we get warp speed.
God.
Which is not possible under current physics models.
So that's the thing. Like if you've ever played Kerbal 1 and people are like, oh, it's so unrealistic. There's the speed of light, the transmission. You need to install a mod to slow it down. Yada yada yada. Right. This is the whole. You instantly get your results back. That's the speed of light. How long did it take to get the signal back? 86 minutes.
82, 83 minutes.
82, 83.
Hit the plus button on the bottom so you can speed up to like faster. No, below.
That
middle.
one. Yep, got it.
Hit plus. Now you got to zoom out faster because now you're going 10 times, 30 times the speed of light. There you go. Now you're going really 60. And it's still slow. And that's just in our backyard.
Yeah. And this is always a thing that sort of comes up, you know, when we're talking about visualizing or trying to experience the spaceflight experiences. You're playing Kerbal Space Program, you're doing something in Eyes on the Solar System here. Speeding up time is always super important. Because a lot of the real-world space stuff is hurry up and wait. It's like, send the signal, and then we're going to wait 14 minutes to hear back from Mars, right? Or you do a launch, and you're in a coast phase, and it's like, now we coast for, 7 months while we go there. So it's interesting that in NASA Eyes and in Kerbal Space Program, there always has to be this experiential thing to dilate time. I don't know if dilate's the right term, but it sounded cool, so I said it. You always have to be able to speed up time in order to experience these things. Is that like a normal thing that y'all have to deal with?
Oh yeah, the scales are massive, the speeds are slow. It's nuts. Even the speed of light is too slow. You have to speed things up.
It's like
and
not even there yet.
We have the small toy system in Kerbal.
Go to above, click on above Earth, because we can see, left side.
Oh, above Earth. There we go.
Yeah, click on above Earth. This is Canberra. Canberra, Australia received the signal. So just due to the way the Earth was rotating.
Right. Oh,
there it goes. Bam. It finally got it. And of course, in California, this was 4 a.m, which was rough. We had a TV broadcast and everything.
I'm trying to see if I can. Oh, there we go. Okay, that's how that works. You grab the whole bar and move it.
Yeah. And you can zoom in on the timeline for finer usage.
Aha. I want to see if we could see. I'm just going to let this run and see if we. I don't know how close it is the problem. Okay, yeah, there you go. That did work. All right, so that's real-time signal coming towards the Earth, if I've got this correct, right?
Yeah, it's fast once it's there.
Yeah, once like the frame of reference sort of gets down. But Bob, that's what you were saying. That's why the Kerbal system, the original Kerbal system, was sort of scaled down,
Yeah.
so it didn't take you as long to get places.
Yeah.
It's
Yeah,
you
yeah.
said like
Here comes, bam.
there it went, bam.
Yeah, so from a gameplay standpoint, to your point, that it's like having those really long burn times, really long waits. Make it small enough where you can make it playable, right?
Yep.
But also big enough where you still need stages. It's still realistic, still a fairly decent game.
Yeah,
I
that's
think
it.
Kerbal is not a simulation; it's a game, right? So
It
gameplay
is.
kind of is king, but again, you learn some good stuff from it.
Yeah, that sort of gets us into another question, like the difference between Eyes on the Solar System and then Kerbal Space Program proper, whichever one you're talking about, one or two. In Eyes, it's sort of all visualization, right, Jason? It's you can't crash the spacecraft together, you can't turn on their engine, and what would happen if I did this? It's just visualization of the data, right?
Yeah, it's just a simulation, show where everything is. And then with Earth, we add data. And of course, the imagery of all the planets is real.
Yep.
So the idea is to show the depth and breadth of NASA and inspire wonder and show everyone what's possible and what's out there already and what's been accomplished already, which is amazing.
Yeah. You sort of contrast that with Kerbal. Like the original Kerbal is an interactive game. It's not just hit the button and let's watch this thing. It is if I want to go watch something, I need to build a spacecraft and fly it there so I can fly through this, fly by this moon or whatever. But the physics simulation is a big part of it. Like there's no physics
Brilliant.
simulation.
I can wholeheartedly recommend it for any physics student
Yeah.
and anyone studying orbital mechanics. Like I'd say play with Kerbal.
We just have a lot more explosions than you'll have in Eyes.
A lot more. There are no explosions anywhere in Eyes, right, Jason?
No, they won't let us. Like for the self-destruct, that's getting crushed. Oh, can you go click on the label back there? Can you see Cassini or Saturn and click on the label back there?
Sure. Like you
Click on-
mean
Yeah, go click on Saturn,
there's Saturn.
double click it. And now click on Cassini,
There it is.
double click it. Let's go its point of view. There you go.
Oh.
Zap, zap, zap.
So
now
that's
now fast forward a little bit and watch him die. Watch this. we can't crush it. That's a lot of animation. We don't
This
know.
is as Kerbal as it gets.
yeah, this is as Kerbal as it gets. So
Crank it down so we can see Saturn. Crank it down.
there it is.
There we go. Now go. Yeah, go. There you go. Go like 10 seconds.
Yeah, I'll back it off once I get there. I've done this in Kerbal too. It's like you time warp too far and it's like, where'd my spacecraft go? So
Yeah. So this is it's a beautiful death.
so this is the final orbit, the final transmission. It's talking to Earth for the last time. It's shooting the gap, not even between the atmosphere and the. Oh, there it went.
Oh, it's dead. See, no explosions, no crushing. It got crushed to molecules, but we can't. That's a high budget for animation on that. I'll tell you what.
So that's the same as in Kerbal. You're in the tracking station and you're fast forwarding, and a spacecraft just disappears because it was in the atmosphere somewhere, and the game decided, I don't think that would live through that, and it just deleted your little spacecraft.
Guilty as charged many times.
Oh, click on Saturn, would you? I want to show you the
Sure.
shadows changing over the years. The top, the second button on the top.
There you go. Got it.
Oh, the third. Sorry.
Oh.
Yeah, click on Saturn seasons.
Seasons. There we go.
Yeah, this is cool. This is cool. Watch this. Fast forward time. Watch the shadows.
So it's got, you can sort of jump around and look at everything yourself, or you can do through these like guided tours, I guess you could say, right?
Yeah, you're basically self-directed. Yeah, you kind of have to go exploring. Kids are really good at it. Adults are like, what? They stop.
I think
Isn't
that's
that
probably
cool?
true for kids and adults with Kerbal as well.
Yeah, zoom in on that a little bit. So it's cool that you can see equinox right there. And then this is what it looks like. And you can see the time in the bottom left. This is a 15, 30-year cycle here.
Yeah.
We're just going back and forth. That's super cool. That's the rings casting shadows on the planet. And of course, the planet casts a shadow on the rings as well.
And
There
it's
you
just
go.
like the inclination of Saturn and its orbit around the sun and the inclination of the rings and stuff like that versus it going around the sun, right?
Yeah, winter and summer on Saturn.
No kidding.
Yeah, pretty cool.
Jason, you guys have the hexagonal storm
Yes,
too?
yes. Go click back to Saturn on the left top.
Got it? Oh, yeah.
Yeah. So this is real imagery. It should come on. Or not. Where is it?
I didn't program it.
Try the other side.
Yeah,
Try the
it's
other-
zooming me in on
there.
I guess the North Pole there.
Yeah, I don't know why that's not playing. But yes, we have the actual imagery of the.
Who do we contact to put in a bug
That would-
report for that? You?
That would be me.
That would be you, Jason. By the way, this isn't loading. Like
Yes.
a slight,
weird.
a slightly more complicated process for you, right, Bob? It's not just Bob, fix
Oh, yeah.
this.
I get it all the time in chats.
It's like a
Let me show
wiki
you
or
some-
someplace you log in or something. So
I have a cool snake storm, so go back to Saturn again.
okay, got it.
I'll show you a different storm. Let's see if this one is not working also. Well, Aurora is pretty cool. Yeah, click on the Aurora. Let's see if that shows up. If that doesn't show up, there's a real bug. Oh, yeah, there it is.
Yeah, there we
So-
go. There's some auroras there. Yeah.
Yeah.
There's the hexagon. There's the hexagon.
Yeah, you can see the hexagon. It's built in. There's also a nice hexagonal kind of motion graphic.
Yeah. All good.
Sorry, I don't. If you have questions, go ahead. But there's so much to show you here. Like,
Oh.
just click on the pictures in the top right. It looks like 2 frames.
Got it.
Yeah, click on that. Okay, now you can see the actual picture on the right and our simulation on the left.
Enhance. Nice.
Right, that's the real picture of the plumes and Enceladus. Okay, now go click on Cassini view. That's how far away it was when it took that picture. And
Really?
now scroll around in 3D there. Show it. Yeah, look at that.
Yeah. So there's Cassini, and it's got the I guess, I'm gonna say field of view. I don't know this. What's the right
Yeah.
terminology for that, Jason?
Frustrum.
Frustrum.
Yeah.
Bless you.
Yeah, field of view is probably better. FOV. So the FOV is there, and that's how far away. And go to that gallery. Like, there's so many cool pictures you can see.
Yeah.
Um,
And the
see how far away
simulation
it
shows you where the spacecraft was when it took that picture, and that just like seamlessly zoomed right into it, huh?
yeah. Go click on the rings crisscrossing on the bottom right almost. Crisscross next to last.
There we go.
Yeah.
Got it.
Look at this. This is so cool. And look at that. That's our sim. We're not even cheating. We are not cheating. We're literally just putting it to the time.
We're
And
not
look at-
even cheating. You're not doing anything like making the entire universe rotate around your spacecraft or anything like that.
Who would ever do that?
Who would ever do that, Bob? Right? That's crazy talk. Why would you do that?
Yeah, so there's a whole gallery there. That little grid on the bottom right, all the way to the right. Oh, there's the ornaments, the Christmas bell.
And Jason, I'm going to say really quickly, it's really cool the way that all this is animated to give you perspective, right? It's not just you click on it and then the picture loads and you're done. You click on something and it actually sort of zooms your view around. It's like, here's the spacecraft and context. You're looking through the instrument, zoom in, here's the actual imagery. Like, the fact that you've done that it really does add a lot to it because it gives you that context as you fly around or zoom in or out or whatever. That's really fantastic.
Thanks.
God.
I'm a little bummed because this is going to be really difficult WebGL. I
The
don't
same
know.
sort of thing in the web version?
It's not going to be as elaborate as the video game version. It just can't be.
Yeah, God.
It's just too bad. But then we open it up to so many more people with mobile phones.
Yep. I'm going to ask one more question because we sort of got off in the weeds there, and we're asking a lot of other things. But one thing really quickly, I know we handled this earlier. I'm going to hop us back over to this is the web version again, right? And
Yep.
I'm just going to go back to the International Space Station. And we had talked about, the ground below this. I clicked the HD and turned on the HD imagery, which is like yesterday's satellite photos of Earth or the background here. Bob, I was thinking that would be a cool thing if there was a mod or something that would update the weather patterns on a planet every day. Let's not even get into that right now, but
Let's not.
yeah, right. But there was a question here about the ISS and how often do you update the model of the ISS? You had said like there was a PMA that was out of position or something like that, et cetera, et cetera.
Yeah. PMA, PMM, and
The beam.
beam. Yeah, those 3 are being fixed shortly.
Gotcha. And is that just you wait until there's enough changes? It's not like, oh, geez, yesterday they did something. We better change that tomorrow. That's just you update that as you can, or how does that work?
Yeah, it's just you got so many models to do that this one was a colossal effort, and we got it exactly right for when we put it out, and we just kind of slept on it. And then the astronauts run out there and move stuff around. We're like, And then I had an actual astronaut who had been to the ISS in front of me while I was showing this.
Really? And they're
I'm
like,
"Oh."
actually, that's wrong. Like,
Yeah, I'm like, tell me about, but I just asked. It was awesome. But she told me she hung out at the top of the solar panel, and then she realized she was the person farthest from Earth in the world. It's pretty cool.
No kidding. Well, I know we're running out of time. We always run out of time on things like this, but I'm going to point out one more thing that I saw earlier. I was you showed me the cheat code, the click on the clock 6 times, and I wanted to show this really quickly because in order to do this in Kerbal, I have like a Kerbal save where I do this, but you have to install a mod in regular Kerbal. But watch the body of the ISS and how how it is in relation to the Earth. If we fast forward, I was amazed that you actually had this in here.
Yeah.
But the ISS is flying just like the ISS flies. It always flies with the nadir side down. The cupola bottom of the ISS always sort of looking down towards the planet. And you have that modeled in here.
Oh, turn off the light so you can see the darkness and the sunrise.
Oh, yeah, there you go.
All right, now watch. You'll see it turn red briefly.
There we go. We'll get it that way. We'll let the sun set on our ISS here at the end of the
That's right.
virtual
right.
astronomy.
It'll happen quick.
Nope.
Nope.
Okay, back.
There you go.
And there you go.
Oh,
Wow.
look at that. Yeah.
So we could go all the way up to right there. It's back to sort of the real color.
Yeah.
Just let it go.
Yeah, you can watch it in real time. It's pretty cool.
Yeah. No kidding. And that's the same sort of thing. You could in old KSP you could install a mod and it would do the same sort of thing as you went through. It sort of scatter the light effect, and for just a split second your spacecraft would sort of flare red like that as it got all the I'm going to say all the pollution in the atmosphere, all the particles and everything like that scatter out the other colors and just leave you with some red making it over there, right?
Mine's more re-entry.
Yours is more re-entry.
Yeah, look for the sun. You can see the sun. So crank it around till you see the sun.
Yep.
Back there. There you go. Look at that.
Yep, and the sun's going down. You can see the color on the ISS actually change as well.
Yeah. And that's on your phone, everyone. You can do that on your phone.
God, no kidding. Well, something. I'm a couple minutes over here. Let's get everybody back together because it's time for us to sort of hop on out of here. Summer, you're back on now. Folks, wait, were you muted there? You might have been muted. I think you're back.
Am I back?
Yes, you're back. Okay, now we can hear you. Good deal. Folks, that's going to bring us to the end of our virtual astronomy live. I mean, we could literally just sit here and play with this stuff. You're lucky I didn't load up Kerbal. Because we would have been here for like 6 hours if I was playing Kerbal and NASA Eyes at the same time. It's like, oh, let's make this mission in Kerbal, and then let's go look at it in Eyes, and let's go back and forth. That would have been a very long stream, but that is going to be the end of today's virtual astronomy live show. Thank everybody for joining us back from home. With us today, as always, Summer Ash, thank you so much for joining us here.
Always.
Alrighty, Bob Palmer from Squad. If you have ever installed a mod for Kerbal Space Program, you may know him as Rover Dude. Bob, thank you so much for the time, just sort of sitting out, hanging out with us here today. Alrighty, and Jason Craig from JPL, working on the NASA Eyes on the Solar System visualization. Jason, thank you so much for your time today, joining us here for Virtual Astronomy Live. We appreciate it.
Of course, anytime.
I feel like we could just sit here and just have you drive us around NASA Eyes for like 8 hours straight and we wouldn't run out of stuff to see. So,
sure.
Good deal. Well, y'all, as we sort of come to the end of the show here, I want to say thank you to everybody back in chat as well. Thank you for joining us too. We do these every month. I think this is the 5th one that we've done here. We change up the topic every month, etc., etc. You can find out more about it by going to intrepidmuseum.org.com.net, whichever one it is. We'll put the link in chat real quick. Which one was it, Summer?
It's com.
It's com.com. Thank you. Jeez, Dawes. If you didn't know that, you can keep up with us over there. Whenever we announce the next thing, we'll have like a sign up where you can get a reminder, like an Eventbrite sort of thing, etc., etc. You can also follow along on Twitter. I'll put some Twitter links in chat so you can follow as well. Also, I can say we do have the program for next month already set. Next month we'll be back talking about asteroids, right? Yeah, exploring asteroids in our solar system. And that's coming up on September 17th next month for that next Virtual Astronomy Live with Intrepid Museum. So hopefully y'all will come back and join us for that. Also, again, I always say the shows don't just magically show up. Number one thing that allows us to do the shows is you. You keep showing up, you keep watching, you ask great questions, you post up about it, you like it on Twitter, whatever it is you do. If you're watching back at home in chat, thank you so much for joining us. And also, I'm going to do it again, the Intrepid Museum's Virtual Astronomy Live event is supported through a NASA cooperative agreement awarded to the New York Space Grant Consortium. And I even said consortium right that time. I also added their logo to the website because I'm like the guy who has to turn on the microphones and edit the web page and make it and do this. We do lots of stuff here so we can bring these shows to you. But thank you so much, everyone, for joining us today for Virtual Astronomy Live. We will be back next month. On the way out, thank you so much for all of the imagery that we had today from NASA JPL, of course, with the Eyes on the Solar System, Eyes on Exoplanets, all those apps that we were looking at. And then also we had some Kerbal Space Program 2 Squad Intercept games in private division. But for now, that is going to be the end of our show. And we will see y'all next time. Thanks so much for joining us.